Hi there, my name is Kasim. I have a master's in neuroscience from Queen's University in Ontario. I have a bachelor's in computer science from Sharif University in Tehran, and I attended Neuromatch back in 22. I've been a data scientist, machine learning engineer for a while. I worked with NLP back in Tehran, and in Vancouver, I've been working on fine-tuning large language models. So yeah, let's recap some fundamental concepts before going into the code. What's gradient descent? Gradient descent is essentially a treasure hunt where you're blindfolded, like you have no clue, and the treasure is to minimize the loss function. Imagine you're standing on a hillside, and your goal is to get to the bottom where the treasure lies. At each step, you feel the ground beneath you, and to determine the steepest direction to to take a step downward. In machine learning, this hill represents the loss function landscape, and the steps you take are adjustment you make on your model parameters. What's autograd? Automatic differentiation is like having PyTorch to keep track of all the operations performed on tensors on your variables. And tensor is basically very similar to NumPy arrays, but they're optimized to work with by GPUs. It's pretty useful autograd because you manually calculating the back propagations can get really complex. Let's just dive into the code and implement one single neuron. I just hide this, but I'm gonna use Copilot to help me. Just type faster. This is how you define it. It's a convention to have it capitalized. And this is a constructor method for any class. So we want to make sure that W and bias are floating points. And then we want to make it tensor with requires grad goes true. It's like telling PyTorch, hey, just keep an eye on this variable for me. I got to import torch. So this is how you define your variable, your one neuron. You cannot do that, of course, because it's an integer. We just made sure it's a floating point. And let's see, this works. Doesn't really matter. Let's implement the forward pass. As you can see here, we take x and then calculated everything. This is the forward function. Kind of right, but not quite. So I want to make sure that x is an instance of a tensor. And make sure you have it capitalized. It's the type name, capital T. And this is how we do it. We also want to apply this activation function. I think Copilot is suggesting that we use sigmoid, but we're going to use tangent hyperbolic and then return it. Yeah. So let's say we have an input to call it feature, and then let's see this. So it applies it predicts it for this value. And one last thing is that we want to also define loss function. So this is pretty good. Just want to auto tab it. And I think let us use, this is the mean squared error. So this is the true y, and well, let me use this true y and the predicted y. So first assert that that they are first answers again for the prediction, and then the squared error loss would be this. So let's just return it. And then voila, we have everything. So let's just have a target as well and compute loss. Print, let's say this is the loss. Yeah, pretty cool.